Welcome to the deep dive. If you've, spent any time working with large language models, you definitely know the big problem. You want accuracy, facts you can trust,
Right.
but that usually means going for a huge, really expensive model like GPT-4o.
The frontier models, yeah.
And if you try to save money, go for speed with a smaller model. Well, you often sacrifice reliability. You get those hallucinations, the made-up stuff that just kills trust.
It's that constant battle, isn't it?
Yeah.
Scale versus, well, substance,
Uh-huh.
accuracy.
Mm-hmm.
But what if that whole relationship, size equals accuracy?
Yeah.
What if that's not quite right, or at least not the only way?
What if reliability isn't just about size, but maybe about discipline?
Exactly. That's the really interesting idea in the research we're looking at today.
Okay, so tell us about the source material.
Yeah, so we're diving into research introducing Humains-Junior. It's a small language model, just 3.8 billion parameters. Tiny, really.
It's tiny compared to the big ones.
Absolutely. But the claim is it matches GPT-4o in factual accuracy on a key benchmark.
Ah.
And it does this using a technique they call exoskeleton reasoning.
Exoskeleton reasoning. Okay, so our mission today is to unpack that. How does a model that small get performance like a giant?
And what does that actually mean? We need to look at the technique, the evidence they provide, and the implications.
Right. For you listening, this could change how you think about deploying reliable AI without completely blowing your budget. It's about turning this insight into something you can use. Okay, let's start with the core finding, the comparison. They use the AFTA-TS grounding benchmark, a specific subset, Q1 to Q500. GPT-4o gets what score?
GPT-4's baseline is 73.5% accuracy. Pretty solid.
And Humains-Junior, the little guy.
It scored 72.7%.
Okay, wait. That's less than 1 percentage point difference? 73.5 versus 72.7?
Exactly. It's incredibly close. And that's really why this is getting attention. They didn't just say, oh, look, they're close. They actually did the statistical work.
What kind of stats are we talking about?
They used something called the 2ST procedure. Two one-sided t-tests. It's basically the standard way to prove that two things are not significantly different, to prove equivalence.
Not just similar, but statistically equivalent. And did it work?
It did. The 2ST analysis confirmed the difference was well inside a plus or minus 5 percentage point margin they set for equivalence.
So for this specific task, factual grounding, they perform essentially the same.
That's the statistical conclusion, yeah.
Okay, now, here's the part everyone managing budgets needs to hear. Same accuracy, basically, but the cost.
Ah, yes, the cost. Based on managed cloud pricing, they use Microsoft AI Foundry figures. Humains-Junior is about, get this, 19 times cheaper to run than GPT-4o.
19 times, that's not a small difference.
It's huge. It completely changes the economics. We're not talking like a 10% saving. It's multiplying the number of reliable interactions you can afford by nearly 20.
And does the cost advantage stop at cloud services, or does it go further?
Oh, it goes further. Think about edge deployments or self-hosting.
Right, running it on your own hardware.
Exactly. If you need high reliability, maybe for like a customer service bot handling thousands of queries, running a frontier model gets expensive fast.
Prohibitively so, maybe.
Could be. But Humains-Junior is so small, if you run it on your own servers, your own edge devices, the cost for each additional inference, it gets very, very close to zero marginal cost.
Wow. So it's not just cheaper per interaction, it removes a fundamental barrier to scaling reliable AI. You can go from maybe hundreds of reliable interactions a day to potentially vast numbers.
It basically kills the economic argument against using high reliability AI much more widely.
Okay, so if size isn't the whole story, it has to be the method, this exoskeleton reasoning. What is it? The name sounds like some kind of external support.
That's a really good way to think about it. It is an external support. They call it a minimal directed validation scaffold.
Okay, minimal directed validation scaffold. Sounds technical. How should I picture that? Is it just a very clever prompt?
It's more than just a prompt, though the prompt is part of it. Think about how a small model usually works. It tries its best to be helpful, right?
Yeah, sometimes too helpful, making things up.
Exactly. The exoskeleton is this external structure, primarily delivered through the prompt, that forces the model to kind of stop itself, to interrupt that default be helpful mode.
Ah.
And it makes it follow a strict checklist, a thinking process, before it's allowed to generate the final answer. It imposes a structure on its thinking.
So it's like forcing it to show its work, like a teacher making a student write out every step.
That's a great analogy. It enforces specific cognitive steps. The sources show this in Figure 2. It basically asks the model to check 3 things first.
Okay, what are they?
1, what do I actually know from my training? Two, what don't I know, especially when I compare my knowledge to the specific context I've just been given? Where are the gaps?
Identifying gaps. Okay. And the third.
Three, is the question itself even valid based on the context? Does it make sense? Sometimes
Sure.
called premise correction.
Interesting. So it's building and self-critique. Now, how did they train the model to follow this? You can't just tell it to do it, right?
Right. And this is crucial. The fine-tuning wasn't about teaching it facts or answers. It was about teaching it protocol compliance.
Protocol
Yeah,
compliance.
they call it epistemic discipline, teaching it how to rigorously follow that three-step reasoning process.
And the training data wasn't from the benchmark itself.
No, they're very clear on that. Zero exposure to the FCTS benchmark content. The training used reasoning dialogues from completely different areas like AI in cars giving advice, complex customer support chats, sales advisory scenarios.
So situations where being precise and sticking to the facts really matters.
Exactly. But none of the specific benchmark questions or answers.
Okay, but how can they be totally sure? You know, benchmarks are tricky. Couldn't some information have accidentally leaked in, some proxy that helped it?
That's always the concern with this stuff. They addressed it with the ablation study, basically testing things piece by piece. We'll get to that. But the immediate clue is this. When they ran the fine-tuned model without the special exoskeleton prompt at inference time,
Yeah, what happened?
its score didn't improve at all. Zero gain. If the fine-tuning had secretly taught it the answers, the score should have gone up even without the prompt forcing the steps.
Ah, okay. So the fine-tuning only taught it the method, the discipline, not the answers.
That's what the evidence strongly suggests, yes.
Right, so the ablation study is where they really proved this, testing the pieces separately to show you need both parts. The fine-tuning for discipline and the scaffold, the checklist for guidance.
Precisely. They started with a decent base model, Phi 3.5 instruct, and then isolated the effects. First test. Just used the scaffold prompt, the checklist, without the special fine-tuning.
What did that do?
It gave a small boost, about plus 3.5 percentage points.
Okay, better than nothing, but nowhere near GPT-4o level.
Nope. And critically, that small gain wasn't statistically significant, which kind of confirms what we often see with smaller models, right?
What's that?
They struggle to follow complex instructions reliably. You can give them a great prompt, a great checklist, but they often just don't quite manage to stick to it consistently. Protocol compliance is hard for them.
Okay, so prompt alone isn't enough. What about the fine-tuning alone? The disciplined model, but run without the exoskeleton scaffold prompt.
And like we just mentioned, that showed a 0.0 percentage point gain, flat.
Right. Confirming no contamination and showing the discipline needs the structure to be activated.
Exactly. The training created the potential, but it needed the scaffold prompt to actually make it happen during the task.
Okay, now the big one, the combination. Fine-tuning plus the scaffold prompt at inference time.
This is where it gets dramatic. A huge jump, plus 17.7 percentage points improvement, and highly statistically significant.
Wow, 17 points. That's massive.
It really is. And it shows this incredible synergy. They calculated it as like a 5.1 times amplification compared to just using the prompt alone.
5.1x synergy, so the two parts together are way more powerful than just adding them up.
Way more. The fine-tuning acts as the enabler. It's what makes the small model capable of reliably executing that complex, multi-step reasoning the scaffold demands.
So the training builds the skill, the scaffold directs the skill.
That's a perfect way to put it. Without the training, the scaffold is just, a suggestion the model might ignore. With the training, it becomes this enforced, reliable thinking process.
Like the difference between giving a complex checklist to a brand new trainee versus a seasoned expert.
Exactly. The expert has the discipline to follow it perfectly every time. The training builds that discipline in the model.
Okay, so we know it works. We know the synergy is key. But how does it actually stop the model from making stuff up, from hallucinating?
Yeah, the mechanism. The paper argues something really interesting. They say factual errors or grounding failures aren't usually because the model lacks knowledge or can't reason. It's an attention allocation problem.
Attention allocation, meaning it knows the right thing, but it's focused on the wrong goal.
Pretty much, yeah. Think about it. Standard LLMs are optimized to be helpful and coherent. Their main goal is often to give a direct, seemingly useful answer. even if the info isn't actually in the provided context.
Right. It prioritizes answering the user directly over sticking strictly to the facts given.
Exactly. The exoskeleton scaffold forces a shift in attention. It activates the model's sort of latent self-monitoring abilities. It makes it prioritize validating against the context over just blurting out the most helpful sounding answer.
Okay, theory makes sense. Let's make it concrete. The paper had that co-sleeper example, right? That really illustrated it.
It did. It's a great example.
Mm-hmm.
The user asks a simple question. What is the best co-sleeper for me and my new baby?
Okay. And the model is given some context document.
Right, a document that lists, say, 10 different co-sleepers and their features, but crucially, it doesn't name one as the best.
Got it. So what did the baseline model do without the scaffold?
It did exactly what we were just talking about. It defaulted to being helpful. It ignored the fact that the context didn't pick a winner and just hallucinated one.
It made one up.
Yeah, it confidently stated something like, the Chico next to me magic is the best co-sleeper, which completely contradicted the context. And predictably, it failed the evaluation. 0 out of 3 judges approved.
Because it prioritized giving an answer over giving a correct answer based on the provided info.
Precisely. Its attention was on be helpful, not be accurate to context. Now compare that to the scaffolded version. Same model, same context, but with exoskeleton reasoning applied.
What happened then?
It was forced through the 3-step check first. What do I know? What don't I know relative to context? Is the question valid? And its internal analysis was something like, the context does not specify a particular brand or model as the best.
So it recognized the limitation in the source material.
Correct. Only after acknowledging that gap did it generate its response. And the response was something much more careful like. The provided text describes 10 options, but doesn't declare one best. Here's how you can use the guide to decide. And that version passed with flying colors. 3 out of 3 judges.
Wow. So the scaffold essentially taught its self-awareness. Pause, check the facts provided, then answer, prioritizing the context even over the impulse to just give a definitive sounding response.
That's the core mechanism, yes. Redirecting attention to context validation.
Okay, this process sounds really effective for small models. Does it do anything for the big guys? The frontier models that are already pretty good?
That's a great question, and they tested exactly that. They applied the exoskeleton reasoning principles, just using prompting, no retraining needed for these big models.
And
significant improvements there, too. GPT-4o, which already scored well at 73.5%, jumped by another plus 11.8 percentage points.
just from the prompt structure, that's a huge boost on an already strong model. Puts it way up there.
Yeah, pushed it up to 85.3% accuracy. And Gemini 2.5 Pro saw a boost too, plus 5.0 percentage points. Interestingly, that took Gemini to the highest score in the whole evaluation, 93.3%.
Wow. So this structured reasoning approach isn't just a crutch for small models, it actually enhances even the most advanced ones.
It seems to be complementary, yeah. Even models with their own internal thinking modes benefit from this kind of explicit external structure forcing validation. It underlines the power of protocol.
Beyond just the peak performance scores, the paper mentions something about predictability, stability.
Yes, and that's arguably just as important, maybe more so, for real-world deployment. Humains-Junior, with the scaffold, showed 25% lower variance in its performance across the tests compared to the baseline model.
Lower variance meaning it was more consistent, fewer wild swings in accuracy.
Exactly. More predictable. And when you're thinking about deploying AI systems, especially autonomous ones, making decisions without a human checking every single step.
They need that consistency badly.
Absolutely. Lower variance means fewer unexpected failures, lower risk.
Yeah.
It means the system is more robust, more dependable day to day. That's critical for things like agentic systems.
Makes sense. One last detail on their methods, the judges. They used other AIs, right? Gemini, GPT-4o, Claude to grade the answers. Did anything interesting come out of that?
Yeah, that was quite revealing, actually. They found that the individual AI judges showed noticeable biases.
Biases? How so?
Well, for instance, the Claude judge tended to systematically rate GPT-4o's outputs higher, while the GPT-4o judge tended to favor the outputs from Humains-Junior.
Huh. So the judges weren't perfectly neutral.
Individually, no. But here's the fascinating part. Because they used multiple judges with these different, almost opposing biases.
They canceled each other out.
Pretty much, yeah. In the final aggregated score, these individual biases effectively washed out, leading to a more balanced and hopefully more objective final evaluation.
So it's a built-in check against skewed results. That actually validates using a multi-judge system itself.
Exactly. It provides empirical evidence that a diverse judging panel Even an AI one can lead to more robust evaluation. Another win for structured diversity, you could say. Hashtag tag outro.
Okay, so wrapping this up, the big picture from this deep dive seems clear. Factual reliability in AI isn't just about throwing more parameters and compute at the problem.
Right. It's very much driven by structure, by process, by what they call epistemic discipline.
And this exoskeleton reasoning shows that a small, efficient model, if it's rigorously trained and guided to follow a strict validation process, can genuinely perform on par with giants like GPT-4o on specific factual tasks.
Which has massive implications for cost and scalability, as we discussed. But there's one final crucial point for you, the listener, to really think about.
Okay.
It's about where the responsibility for truth now lies. This method, exoskeleton reasoning, trains the model to prioritize the context it's given above almost everything else.
Even above its own internal knowledge of facts.
Yes, even if the context explicitly contradicts known facts. The example they use is instructive. If the context document says the capital of France is London,
Which is obviously wrong.
obviously wrong.
Yeah.
But the model, following the exoskeleton protocol correctly, must state that the capital of France is London, because that's what the context dictates. It's trained for obedience to context.
Wow. Okay, so that completely shifts the burden of verification, doesn't it?
Fundamentally, it means you have these different ways you might deploy it. Maybe context dominant, where you fully trust your provided documents, like in many RE systems or for benchmarks. Or maybe you need a safety override for sensitive topics.
Or some kind of balance.
Right. But the core point is you can trust this kind of model to be incredibly obedient and grounded to the context, which means you or your team become absolutely responsible for ensuring that underlying context is accurate and true. The model won't save you from bad source material. It will just faithfully reflect it.
So the AI becomes reliably obedient, but the ultimate truthfulness depends entirely on the quality of the information we feed it.
Precisely.
That's the strategic shift to grapple with. Highly reliable, cost-effective AI is within reach, but it demands rigorous quality control on our end. So the question for you is, what information, what domain are you responsible for validating to make sure your AI's accurate answers are also true? Something to think about until our next deep dive.